Wait for it, wait for it, wait for it. Okay, and it looks like we're live. So this is August 2021 Lightning Talks, and we will go ahead with our very first presenter. Take it away.
Great, thank you. Thanks, Lauren. Hey, everyone. I hope that you've had a wonderful and productive day. I am going to share my screen and present to you Tuka. So this is a project I started 3 years ago. I was a software engineer at a medical software company, and we had too much code. And it was very difficult for us to refactor a large amount of code without having our test team actually spend hours and days testing. So I started this idea of how can we basically streamline the testing for developers so that when they are making changes, they can run tests that run fast, but also give enough information to them that they can stay confident that they haven't broken the software. And unit tests are very effective, but they weren't cutting it for us. So I started Tuka as a side project. It then started to become an internal tool at our company. And then I got the IP rights and started a startup around it. So now I left my company and I'm now looking for users to use Tuka. The reason I'm giving this talk is to get your feedback. So I'm not trying to sell. I hope that you can let me know if you found this useful or if you have ideas to improve the long-term vision of the company. Now, there is this GitHub organization at TryTuka on GitHub. We have SDKs in different languages. What I want to use today is the Tuka Python SDK. Now, there is an examples directory here that gives you a better understanding of how Tuka works. But today, I just want to go ahead and use the cloud service of Tuka, which is at tuka.io. So I'm just going to go ahead and log in. And here I've created a Python suite, and I want to submit my test results to it. Now, I know that this doesn't make sense yet, so we're going to get back to this page in a little while. But let me just briefly describe what I'm going to do and how I'm going to demo this live. Here on my screen on the right side, you see the VS Code. I'm showing basic, very basic code that you can think of as production code. So the type of code that we ship to our users. So here, imagine we want to test a parse profile function that takes a username of a student and gives a student object in return. Now, this can be very complex. Maybe it's scraping the internet to find information about a given student. But at the end of the day, it's just basically bringing on some information like username, full name, date of birth, and the list of courses that they have. Now, the idea for if we wanted to use unit test is to call this function parse profile that we want to test with different inputs, which in this case are usernames of students. And every time we get the object, which is the student back, then we are going to test different properties against some expected value. I'm sure that you know this already. So this is great. This is very effective. However, if you have to test this function with hundreds and thousands of usernames, then specifying the list of usernames and the expected values for each would become extremely difficult. It's just impractical to use unit tests at that scale. Now, you might say, well, maybe just if we can test with a couple of test cases, that's fine. For certain workflows, that may be okay. But in a lot of cases, our software that we ship to our users is so complex and has such weird behaviors from one input to another that it's very difficult to test all of those edge cases and test cases. At the end of the day, as a software engineer, I want to make sure that as I am writing code, I'm not breaking the software. So the idea is, instead of using unit test, then we basically just describe the behavior and performance of our test without specifying test cases and without specifying expected values, so that we can run our workflow under test with however many test cases that we want. Now, this makes more sense if I show you this, which is the way that I am proposing to write a TUCA test. In this case, we are just going to call a parse profile basic function, which is our code under test, as part of this TUCA workflow. And we can have as many of these in this file. But once we get this student objects, we're just going to say, hey, I want to track the full name of this student, whatever it is in this current version. I just want to take note of that. And so once another version of my code under test is available, I'm just going to run the same test with the same set of test cases. And then when I get back the student object in my second version of my code, I'm just going to let TUCA compare the new actual value against the previous actual value. And then if there are differences, then we want to visualize those differences. That's the idea. Now, I want to do this very fast and without actually involving my local computing resources. So therefore, instead of comparing test results and storing them in files and comparing them locally, I want to just, as I am running these test cases, capture this data and then post them to this TUCA platform, which is basically doing the comparison as well, and then visualizes all differences. So what I'm going to do is to just run this same file, the starter module with some version. So I'm just going to declare that the version of parse profile right now is 1. This can be a git hash or some name, whatever that helps us associate that name with the state of our code at one particular point in time. And then I'm going to pass the test cases that I want to use to call my function. And then I'm going to run it. So as you see, this is a simple workflow. So it ran fast, but as it runs every test case and it passes usernames and it captures results, then it's going to post those results to the TUCA platform. So in real time. And then the platform starts comparing the test results as they come in. So in version 1, of course, we have 3 test cases. The test cases that I passed is this file where I'm specifying the test cases. Now, once we have the test results here, I can inspect them, and the SDKs that we are using, in this case, the SDK for Python, is preserving the data types that let the platform actually compare the test results in their original type, and then visualizes the test results that we submitted. So this particular test case or workflow didn't have any performance benchmarks, but we can also capture the data that describe the performance of our workflow under test. Now, I have a little time, so I'm just going to skip the performance benchmarking right now. And I just want to make a small change in my code under test. So let's just say we want to change the birth date of Alice to 2000, for instance. And then I'm going to run this again. This time, I'm going to pass version 2. But because I submitted the test cases to the TUCA server, then I don't have to specify them again on the platform. The SDKs would obtain that information from the server. So I'm just going to run this again. And then this time, if I go back to my suite, I see that version 2 is submitted. This shows the runtime of my overall workflow, how long it took for me to run version 2, for instance. And then here, I have now some differences in this particular test case, Alice. And if I look, the birth date is different. The new version has a year of 2000, and previously it was 2006. So I can inspect these differences, and if they are expected, if I wanted my function to my code under test to behave this way going forward, then I can just promote this version to be a new baseline of my suite. I can even describe to my teammates why I'm doing this to let them know that the expected behavior of our workflow under test is going to change from now on. Once I promote, the platform automatically starts comparing the new the version against the new baseline, which happens to be itself. I can always use this bar to compare any version against any other version. But at the end of the day, this platform helps developers to actually see the side effects of their code changes as they're writing code. So we want to make this, as real time as possible. And then in the long term, we're going to integrate all of this information with code editors so that you don't even need to come to a separate website to see the results. You just see them in the code editor as you're writing code. Now, there's of course a lot more to code than I could fit into this demo. So if you wanted to learn more, again, I refer you to the Python SDK GitHub repository. And again, please reach out and give your thoughts and feedbacks. There's no QA here, so please, I'd love to hear what you think about this. Thank you.
Thanks so much, Pejman. We can open it up to QA.
Oh, great.
Yeah.
Awesome. So should I share my screen again? Yeah.
Yeah, we can take like 1 or 2 questions.
Okay, great. Any questions? Uh-oh. Did I do a bad job of describing how Tuka works?
I have a question.
Please,
no,
go ahead.
You didn't do a bad job. I was just thinking of like how to phrase it. I wanted to know, you talked about performance benchmarks. Well, you said you wouldn't go over them. Can
Yes.
you go over them?
Yes, absolutely.
Like,
so
yeah.
If it helps, I just switched from Python to some dummy profile database again. So here I have already submitted 5 different versions of this kind of the same code. So now if I look at version 5, for instance, and open up one of these test cases, you see that I have a tab here, metrics, that has a couple of metrics. And here it does have some metrics. It says, like, for instance, this function took 90 milliseconds to run. Now, 90 milliseconds is so low that we are not going to report, differences. If now another version takes 20 milliseconds, we're not going to flag it as different and say, oh, there's something wrong here. But the platform actually uses an algorithm, which is smart enough to kind of give you information when there are substantial changes in the like performance of different parts of your code. And of course, there is Tuka API, fine-grained control over what functions you want to, capture their runtime. So that, these are actually are specified in the code. I'm saying I want to track the runtime of custom function 1. Does this give an idea? Of course, I can refer you more to the examples on the repository.
This makes sense.
Okay.
This makes sense to me, how you were tracking the metrics.
Great. Awesome.
And then,
any other questions?
If we wanted to play around with this, we can just pip install Tuka?
Yes, pip install Tuka is the is the command. And then again, like the example that I showed you is right here. I think I used this one. Now, there are other examples here that you can use. There's actually another repository examples that shows, I think more, so there's one more that shows how to use external files, for instance, track differences in external files. And of course, you can reach out on the intercom or just email me at pejman@tuka.io. I'd be happy to give you more examples and even create proof of concepts for you, depending on your use cases.
Very cool. Thank you so much.
Okay. Thank you. Thank you so much.
And so, John, you are up next. Let me go ahead and replace the spotlight here.
Okay.
All right.
All
you are spotlighted and good to go.
All right. Hi, everyone. I'm John. I'm going to go ahead and share my screen here. Just a moment. First. All right, I've been told sometimes full screen breaks stuff, but let's see how that goes. I'm going to try full screen. All right, hi everyone. You're right. I am John, and my talk tonight is to the dev side. The sleep you save could be your own, and it will in fact be a lightning talk. Try to do it under 5 minutes. So I'm working on the Docker project. Right? Cue the meme. Docker is the best thing ever. Well, Docker's great, don't get me wrong, but during deployment, we had some trouble. We had some Docker health check noise, right? The Docker health checks, they were dependent on an external vault service. And because of that, when that service was down, and unfortunately there was planned and unplanned downtime, we didn't know the status of our own service because it couldn't pull the credentials to run the health checks. The other thing as well, it appeared that that service, which was an authentication service, was down. So there were late night calls to the team. Raise your hand if you enjoy late night calls because services are down. No one, I'm sure. So what's to be done here? I thought, you know what, the original person who created it, the answer came back that, look, these are a pain to change. And I thought, okay, let's jump in here and see what we have. As a dev-minded subject matter expert, let's see what we're dealing with. Sure enough, I looked and I saw there were 6 imported modules, and there's one main module calling. So you can see there's 6 here. You can ignore the import asterisk for just a moment. But I thought to myself, like, surely these are all different, right? I mean, there's a reason for this. However, come to find out, they were all the same, actually, except for the function names and just a little bit of code for each test. So the second question now is, raise your hand if you want to modify 6 files instead of 1. Now, we could have just done it once, but that's kind of a pain to modify the file, test it out, deploy it, do it again 6 times, right? That's going to get boring, old, manual, and just, it's a pain. So we figured, let's do it right the first time and see if we can unhook ourselves from this dependency and smooth things over. So what's to be done here? 6 files. How are we going to manage 6 files? So having thought this through a little bit, the Decorator. Now, I know probably everyone here already knows about decorators, but if you haven't or haven't used them yet, the quick description of a decorator is a function that receives another function, and then it enhances it by wrapping that past function with some sort of modification and returning that past function to the original function name. So as a quick demonstration, you see in the bottom left-hand side, you have a function simply called hello. It prints hello. That's all it can do. But wait, there's above it something called there, a function called there. That actually takes in a function, wraps it, then it allows that wrapped function to print there and returns the whole thing back into the original name. So the bottom line here is that hello, once decorated with there, now it gets to say hello there. And this is frankly probably the simplest decorator you'll ever see. They do get more complicated and complex, but hopefully this just sort of shows the basic usage. Now, if you put your attention on the highlighted green, you can see that that @ symbol is sort of just a syntax. They call it syntactic sugar. It's the same thing as just saying hello is effectively assigned the return value of there being passed hello. Same thing. But the bottom line, there's decoration happening. Now, how did this affect my actual work and my team? What were the net benefits? So we went from 6 modules down to 1, 28 def statements rather down to 8. But most importantly, we were able to unhook and modify that dependency very easily in one file. So now we're only managing one file instead of 6. But the icing of the cake, and from my perspective, the best thing is I'm sleeping better, and so is the team. So a big thanks to Python, and a big thanks for everyone who's been listening. Yeah.
Thanks so much, Sean. And I heard your timer go off, so perfect, perfect. Any questions for John about decorators, Docker, or sleeping better?
I have one about the decorators. So, John, one issue that I found with like I've experienced with decorators is that the documentation for the decorated function has to be explicitly basically wrapped to be accessible. So there is this update wrapper function that Python provides to copy the documentation when you're passing, basically passing a function to, a decorated function. Is that clear, by the way? Did I ask the question correctly?
It sounds like you're saying that the documents need an update to clarify how they're used?
Yes. So imagine you have a decorated function, A, that is basically wrapping around function B. Now, you've documented function B, but in order for your function A to have documentation of function B, then you need to explicitly copy the documentation using the update wrapper function that Python provides. Now, my question here is that if there is runtime cost in terms of performance by by using the update wrapper function.
Oh, that's an excellent question. Just to be very direct, I don't have that information immediately available.
Okay.
I know that there are different wrappers that do interesting things, like you're saying. There's the name sort of changes with respect to the function that is being wrapped, and you sort of lose that. I didn't have enough time to go into that. And frankly, full disclosure, I didn't actually use any of that in my solution. From the infrastructure perspective, it sort of just works, but you do bring up an excellent point. So I didn't actually do timings on my particular
Sounds good.
project here. But yeah, it's if you're having that concern, you might want to do a little bit more
benchmarking.
Yeah, benchmarking and timings. But I'd be happy to talk to you later about it. It's a pretty fascinating
topic.
Thank you. Yeah, sure thing.
Any other questions?
Yes, I have one. Docker was mentioned earlier. How does this, you mentioned there was a failure because something was deployed in a way that wasn't configured correctly, and then you had to chase all this stuff down. How does that happen? How did you I mean, you already told us how you got around it, but I thought the point of one of the big strong points of Docker was it works on my machine, so let's just kind of deploy my machine, sort of.
Right. There's a lot of sort of subtle things in this. The first one was that, unfortunately, for this health check to work, it needs these credentials. So if that vault was down, then what's being sort of experienced by the health check is that there's a failure of the service. So that's what that sort of blind spot was. So if you think it more directly, if the vault is down, my service is down, because I don't know if it's actually up or down, because I'm doing an authentication check on a service that provides authentication. So that's where it wasn't so much that Docker had a problem as much as the implementation of the health check and the underlying code and data that needs to get fed into that health check.
Oh,
Did that
thank you.
help or make it worse? Is that good?
No, I mean, it kind of sounds worse when you put it like that, authenticating.
Yeah, it really does, right?
Thank you.
Yeah, sure thing.
Any other final thoughts? Anyone too shy? Not too shy, but collecting their thoughts. Okay, I think we can move on. Thank you so much, John, for sharing this lightning talk with us. And I will go ahead and remove your spotlight. And next up is Jeremy. And John, if you could stop sharing your screen. Perfect.
Just give me a moment while I presenter view.
And you are now spotlighted for everyone.
Hang on.
Well, we're getting set up here. I just want to remind everyone that if you'd like to speak tonight, we do still have the sign up sheet. It's not required that you are on the live stream. Just go ahead and indicate your interest or not. I'm dropping the link in the chat right now for the spreadsheet.
Well, I'm good to go. If
Good to go, Jeremy. Yep. Take it away.
All right. Hi, my name is Jeremy Fisher. I am a recent transplant to New York, and I'm a software developer at Roivant Sciences. So you might be aware, the title of this talk is the case for structural pattern matching in Python. Pattern matching is a new language feature that will be introduced in Python 3.10. It's something that's generated a lot of controversy in the community, and I really like it. So I wanted to talk about why I like it. So a quick introduction to what structural pattern matching actually is. This is something defined in PEP 636, excuse me, and introduces two new keywords to the language, match and case. You can see an example on the right from a notebook that Guido wrote that kind of shows a typical use case. You match on some expression, and then you have different cases that expression can be destructured into. And that destructuring allows you to constrain the kinds of data that flows through to each of these endpoints in your match statement. For example, if you wanted your code to say the origin when it has a list consisting of a single point going through the origin, you would destructure that with list literal point 0, 0. Or if you had some point that didn't fall on the origin, you could structure that those variables into an X and Y, which would go into the point class, the point object, and then be available as a local that you could use to print, for example. Now, people don't like this because it's a new language feature, and that means it will break old code that uses those keywords. And here's something I just picked up from Hacker News without trying very hard. Anything that breaks and changes semantics should not be allowed into the language. Let Python be Python, not a Frankenstein monster of ideas like C++. So that's the gauntlet. If we introduce the new language feature, does it improve productivity and readability enough to make it worth changing the way that the language has historically worked? So I'm going to proceed by showing an example of something that I think pattern matching is really, really good for. And that's compiler algorithms. What you see here is an assembly program for the hack chipset. It's part of an online course called Nanti-Tetris. On the left, these are the assembly instructions that will be compiled down to a byte string that you could, in principle, feed directly into instruction memory on a CPU. And on the right, I've rewritten them as structured Python dictionaries. And the question is, how do you take what's on the left and programmatically convert that into something on the right? And I submit to you, this is non-trivial. And I want to demonstrate that structural pattern matching takes something that's kind of complicated and actually makes it a lot easier to do. So here's my implementation. This is just a less than 200 line program that does what I showed on the right column. And it's just a 2-pass compiler. So the first pass will parse each line and pass the semantics of that line into a kind of instruction object. And then if that's a symbol, add that to the symbol table and re-render that symbol using the correct instruction memory. That's a detail of parsers that are not of assemblers that isn't really relevant to my point here. My point is that if you do this in a way that you might be encouraged to using normal Python language constructs, you might be tempted to use something like a regular expression. And this is the regular expression I came up with. It is awful. It is full of optional match groups. It's completely unreadable. And on top of that, it needs all kinds of post-processing just to deal with corner cases where a finite state machine isn't adequate to parse very simple semantics of an assembly instruction. So ultimately, this you could probably figure out how it works in 30 minutes, an hour. I don't like it. I think this is inelegant. And the solution I came up with using structural pattern matching, I think, is much more explicit and easy to show you what is going on. We start with a simple if statement and another that does a simple regex. And that's just to deal with some short corner cases. We do the same thing in the normal path in like an older version of Python. But here's where all the other logic lives. Instead of doing a monster regex, do a simple regex, split on any of these symbols and create a list of tokens, and then destructure those tokens based off of what string literals are inside them and reroute the remaining bits of information into the right field of the object and then just return it. So I hope I've convinced you that that solution is much simpler and readable. I'm just going to go back to my slides for a moment to make one final point. And that's to read a quote from Brett Cannon, who is part of the Python Steering Council. There are certain algorithms that are really difficult to do without pattern matching, right? The classic examples are parsers and compilers. They're not easy to do without having pattern matching. There's a reason why functional programming languages that have had pattern matching for a very long time are the best places right now, because the algorithm just works so much better that way. So there were reasons why we wrote this in there, and there will be increases in productivity. So Brett Cannon, no slouch, saying that the reason we're adding more language constructs is to serve a pressing need in productivity and allow Python to expand to different algorithm classes. So that's my talk. Thank you. Any questions? Do we have time for questions?
We do have time for questions. Thanks so much for presenting, Jeremy. I think this was a really compelling case for pattern matching.
Good.
Did you notice that I said case?
Didn't.
As a protected keyword there. All right. Any questions for Jeremy?
Jeremy, could you please share the link to your the code example that you had?
Which one? The one that
the one that,
or?
Yes, the one that you had with your implementation. The
Oh,
second code snippet that you showed. Is there a link to that?
I mean, it's just like a Git repository on my computer.
Okay. Okay. Never mind. Okay. I just was curious to see if I can, get a better idea of how you implemented that. and made the initial regex simpler.
Okay.
Yeah, if you don't mind throwing it in a gist or something, I'd be happy to share it out on our Twitter as well.
Yeah, let me go to gist really quickly.
Very cool. And I see that we do have one more sign up. Yay. There's still a little bit of time to sign up if you are interested in speaking tonight, whether that is going to be streamed or not streamed. No pressure either way. It's strictly opt-in. But Tom, it looks like you have opted in tonight, so I will go ahead and spotlight you.
Yep, I've opted
And
in.
I'm going to drop the spreadsheet link in the chat one more time. Don't let it distract you, and take it away.
All right, everyone see this great C++ code? All right, so this is a very short talk about my setup with VS Code, SSH, and WireGuard, and why I got to this point, how I got to the point. So in my day job, I work on PyTorch, which is a neural network library written in C++, but for Python. So most of this is in C++. The thing is, I don't like working on this on my laptop, and I want to work on this on my 16-core workstation at home because it takes around 13 minutes to compile the library with CUDA enabled, and I don't want that to happen. Like, it takes forever on my laptop. So I'm always SSHing into my workstation. So like if I'm on my local machine, it's very simple. Like VS Code has this SSH remote thing. So it looks at your .sh config file and it populates this with all my targets. I have a Raspberry Pi here, as you see. So my first initial setting was I just connect directly. When I'm on the network, I just connect to the local IP address and it's fine. It's magical. The thing is, when I get out of my home network, I want to connect to my laptop, my workstation as well. So the easiest thing to do is to do a dynamic DNS and have a public domain, the public domain point to your public IP address, and then just SSH through that. So that works fine. It's very nice. This is this one, and I have 4 different versions of PyTorch on my workstation, and so I just connect to it through the port forwarding and straight through the dynamic DNS, and it's fine. The thing about this is it's kind of annoying that every time I start a HTTP server, I have to keep on tunneling through SSH. So like every time I start a web server that hosts some documentation I want to look at, I need to tunnel it through SSH, and so that's not great. And so the last part of my workflow is I set up WireGuard, which I'll put a link in the chat. And WireGuard creates a VPN, and all this does is it connects my laptop to my workstation, and it's on the same network. So I use that IP address to SSH into now. And the cool thing is that if I have a Jupyter notebook, I could use the IP address on the VPN, and you get all the nice things of having things on the server. So if I want to host the PyTorch documentation, let's say like I put it on 9001, that port is opened on that network, and I could just like look at the documentation. And it's very useful when I'm working not at home. So that's it. The big takeaway is that VS Code supports SSH. WireGuard makes it very nice to just connect your laptop to your workstation or a server, or yeah. So that's my talk about VS Code, SSH, and WireGuard.
Amazing. Thanks, Thomas. Any questions?
I have a question. I don't assume you're going to know it, but I'm going to toss it out there. I don't actually use VS Code. I'm kind of a VI guy. But can you do like in that console, if I understand correctly, you sort of can have like a bash shell. Can you have like a bash shell as well as an IPython console, both? Is that like an outrageous thing to do in the
Jupyter environment or the VS Code environment? Just making sure.
Just in the, I guess maybe that VS console.
Okay, so this terminal here is my workstation machine. So it's also SSH into it. So like,
oh, okay.
So it's if you want, you could go in here. I usually many people do this. So many people just use the terminal inside of VS Code and it just works. I like switching back and forth into my Tmux thing, but it's a matter of style. So like this is also connected to my workstation, and it has everything I wanted. Like I could start a Tmux thing here, and you can see that it's all here. It's a standard terminal to my my machine.
Oh, I see. Okay, so that that resolves my mental problem. Thank you.
Yeah. This is very convenient. This whole SSH thing, because it copies your SSH config directly. Yeah.
Cool.
Yeah.
All right, and I see that we have a late breaking sign up. Kim, I'm so excited. Let me go ahead and spotlight you, and I'm going to ask you to unmute yourself and go ahead and share your screen when you get a chance.
All righty.
You know, we used to have these when they were in person. We would always host them at Metas.
Right? Yeah. I remember that. Yeah. Okay, ready?
Ready when you are.
All right, great. Okay, great. So yeah, late breaking presentation. I kind of just put a few slides together. I just learned about this package relatively recently and just thought I would put something together about it. It's called Just Text. So I do a lot of work in Python for visualizations. So this one's about visualizations. Basically, you can see here from the GIF, you can basically automatically update the text labels for your points, and so that the text does not overlap the points or other text. So it's pretty cool that the library can automatically do that for you. And so I'll just tell you a little bit about that library. So it basically is just open source Python library to automatically adjust the positions of your matplotlib text. It was released in 2018, so a couple years ago, by Ilya Flyamer. And you can check it out on GitHub. All of the source code is there, which is what I did to kind of learn how everything worked. You can kind of look through and see how all that goes. Basically, if you think about kind of the benefits here, we're basically going to start with some text over top of all of our points. And the first step to this little bit of code is to take all of the text that's outside of the figure and then move it inside. So that's going to be the first thing. So you're also not running into any of the boundaries, which is pretty great. And then the next step is really to just go around to each of the different text boxes that there are and count how many overlaps there are, and then reduce those overlaps. Just shift the text one direction or the other. All right, so as far as installation, the normal pip install will do it. There's also a Conda version if you prefer that. And the imports, there's really just one main function. It's called adjust_text. I'm also importing for this little code demo, some pyplot and numpy. So let's say that you just created some random numbers and you created a scatter plot for those, went through and labeled everything. The only thing that you actually have to add to this code to make all that automatic text movement happen is just one line. It's just adjust text. It's pretty awesome that you can really just pass in those list of texts and then everything will, again, not overlap with each other, which is pretty cool. There's a lot more that it can do that I'm, not doing justice here. But of course, if you want to use Seaborn, you can continue doing the same sort of thing. If you want to add little arrows from the labels to the points, that's also possible. It can also work with maps and all kinds of other things, lots and lots of examples there. And so I've made a little video about it that I released, I guess it was on Monday. If you want to see more about Adjust Text, you can visit my YouTube channel. All right, that's it. Any questions?
Okay. I am curious. Is it? I think you said it. Is it specific to matplotlib versus like the Boca perhaps, or and so on?
Yeah, from what I can, it's gonna go around and look for the bounding boxes from matplotlib. So from what I can tell. Yeah.
Got it. Cool. Very cool. Thank you.
Cool.
This is the coolest thing.
It's a really simple thing. I'm like, but everybody needs this. So yeah,
Everybody
I've been
needs
trying to
this.
tell as many people as I can about it.
I love it. Okay, and can you just drop in the chat the GitHub repository one more time? I missed that, but amazing. All right, any other questions for Kim? I see a comment. I feel like this should just be built into Matplotlib. My understanding is that that is a legacy code-based beast, so maybe not. Okay, I'm gonna go and turn off the stream. So, and then I'll let you know when it's